So my name's Cass, my pronouns are she, her. I'm the Research Community Manager for Environment and Sustainability at Turing. I'll tell you a bit more about my background tomorrow if you're here. I'm not a climate informatician, I'm a neuroscientist, I was a neuroinformatician, but I'm very pleased to have this opportunity to connect with this audience and learn more about your challenges and things like that. So on our panel today, we're going to be focusing on reproducibility and the practical aspects of reproducibility from like a computational perspective. So going to hear from 3 experts in computational reproducibility, a bit about their background, how they've got to where they are, and then some space for hearing about the challenges that they see and their visions for practical computational reproducibility. So we're going to start with some short presentations from each of our panelists, then move on to questions and then some Q&A from the audience as well. So be sure to put your questions in Slido and we'll have a room mic as well. So first up, we'll be hearing from Marion Weinzierl. She's a senior research software engineer at the Institute of Computing for Climate Science at Cambridge. And then next, you'll be hearing from Alejandro Coca-Castro, who's a research fellow at Turing for Environment and Sustainability. And then on to Dominic, who's the co-director of the Institute for Computing and Climate Science at Cambridge. So I'll hand over now to Marion for our first talk. Thank you.
So yeah, we were each told to prepare 3 slides answering 3 questions. So the first question we were asked to answer is, how do we get here? How did we get here? So I first started to get interested in software reproducibility when I was basically just becoming a research software engineer after spending some time as a postdoc and then some time in industry. I attended a reproducibility hack led by Anna Cristalli in 2019, and it really opened my eyes on how difficult it can be to take up somebody else's code. And I think if you're used to basically work with your own code and it might be complicated, but you've set everything up on your computer and it kind of works, so you sometimes forget how hard it can be for new people to go in and try to use it. And so everybody basically first has to go over this hurdle. I was part of the artifact description and artifact evaluation committee of the Supercomputing Conference in 2021. Which basically has an additional barrier of complication by the fact that you, in order to reproduce results of big parallel runs, you need a big machine to run things on. So that was a really, really interesting experience to do as well. And then I started to organized repro hacks myself. So the repro hack community, the repro hack hub, has a lot of material for basically everybody to pick this up and to set up their own repro hacks. And we had a repro hack of the Institute of Computing for Climate Science as well, where I wanted a Turing way speaker. So I asked for one, and Alejandro said, yes, I'll do it. But in turn, he kind of dragged me along here, and now I'm kind of here as well. So that's how I ended up here. What am I currently thinking about was the second question. And in my work as a research software engineer, it is really about, okay, how can I make it easy and something that people are interested in, who are basically just wanting to write the next paper, so that they actually spend some time on the software and on the sustainability of the software, on software that isn't thrown away when the postdoc leaves or the PhD student moves on, and how can basically this hurdle of onboarding or so be lowered, and how is this something that actually does not need to be imposed on researchers, but something that researchers are actually intrinsically interested in themselves. So, and also how do we do this without them feeling like, I have to spend so much time to do this, and is it really worth it? And what am I currently working on? And it's exactly this. So it's this thing of, okay, how do we do that at the ICCS? And one way I like to do that is that if I approach a new project, or also if I'm onboarding a new RSE to a new project, I'll see it as a mini repro hack. So I see it as an opportunity to look at this new code base with fresh eyes and start not by asking the core developer, oh, how do I do this? And can you help me to set this up? But by looking at what's there, what's in the repository, where's the README, where are the installation instructions, and see how far I get. And then I can put in new issues basically where I fail or where I need additional information. And and this way, basically step by step, trying to improve codes and to point to things and basically, make incremental improvements on the code basis. And then you will hear a bit more about the reproducibility initiative that we've been working on. I think Cass will talk a bit about that. But the idea is that those of you who've submitted full papers will try to encourage, and I hope this will encourage you here as well, to submit your software, your data, so your artifacts to a process where we will work with you on improving and accessing the reproducibility of those. And I think it's next to Alejandro.
Hi, everyone. Just following the same order, I will, in my perspective as an early career scientist, I would like to bring what bring me here and talking about open and reproducible research. Just as summary, but because I'm working with different institutions, but so far those ones that have been more impactful for me, first with the CGR. This is a consulting group around the world, and I was working in a project for 5 years about providing data of deforestation worldwide. And was very impressive project because it was one of the first operational monitor systems, and I was part of this project. But one Delta at that time, and just reflecting what was Delta at the time, this program software was closed, and it was only through institutional agreement. So we never have opportunity to show to the world how the data was processed and so on. So I think that I have, now that I'm working with more in open research settings, I think there are some drawbacks about this approach. Then during my PhD and master at King's College London, I started getting more familiar about data mining and machine learning. And for instance, I reuse this open data of deforestation to try to understand what happened after deforestation. So I get exposure to typical machine learning algorithms at that time. They were emerging like recurrent neural networks, and I analyzed time series. I also did some analysis of shades with data mining, and was a very amazing experience at that time. But because these topics were emerging deep learning for environmental science, I found a lot of frustration when I was trying to run in someone that create this nice algorithm for, I don't know, for a specific computer science application to my domain. That was kind of a frustration, and also to run notebooks and try to follow up what they're doing. So then I will just mention pluses when I joined the Alan Turing Institute, because it's been a fascinating journey since I joined, where I essentially gave more knowledge about open science and like software development. And I've been contributing to Deep Sensor. Maybe some of you have seen the posters that we are working at the Turing. Deep Sensor is a key software that we are now trying to promote and analyze environmental data with that. And as well, I'm contributing to general computer vision application inside Vision. And through this experience, I've been exposed to what we need to create more tools that are not only for papers, for a single papers of publication, but tools that are generating knowledge, and can you have many general applications where possible. And something apart from the technical side, I'm trying to collaborate with communities like Pangeo, that is big data geoscience, and the Turing Way, where I'm gaining knowledge and try to support these activities about reproducible, ethical, and collaborative data science and geoscience. And finally, through this kind of experience, I started an initiative that also you see some posters that is about the environmental data science book that I'm going to mention later. So environmental data science book was an idea that was inserted during my postdoc 2 years back, and essentially I found opportunity through these frustrations that early career scientists can demonstrate and communicate their science through notebooks. And here what we are aiming to answer is to what extent can we educate and leverage good scientific software and data management practices among environmental scientists through co-creating fair executable notebooks. And we have different flavors of notebooks here. Everyone is welcome to visit, but something that was very impactful about this community has been like a platform where last year we run the inaugural 2023 Climate Informatics Challenge and with the Cambridge University Press, and it was a month. The one that participated in the conference last year, we have a it's a final slide where we announce this, and we have around 24 participants from the America, Europe, and Asia. At the end, we have 3 submissions, and all of them are published, that first row, and you can run what they did with these reproduction reports. We have some peer review pre-review process where these volunteer reviewers improved the version of the reproduction reports. Was very positive experience. We have different onboarding, like guest speakers and drop-in sessions, and thanks to the collaboration with the Pangeo community, we got like cloud computer resources with a deployment that is using like regional resources by the European Open Science Cloud. Okay, and I guess I would say a nice like kind of frame all these activities we run is that we ended like having a position paper for now the Climate Informatics Conference, where we are trying to frame and trying to have the big picture where we would like to have from these experiences. This is going to be published in the special issue, but I'm just going to summarize here briefly. So this is the current state of the Climate Informatics as we all the authors note. Like we have the typical funding that is through do your science and get the manuscript, and the way that we have the trust and reward is basically because we publish papers and have this acknowledgement and then get more funding. And of course, we separately, like with our own resource, the Reproducibility Challenge, where essentially with volunteers around the world, we're aiming to try to reproduce the publication of these papers and try to have this DOI citable notebook. So what we propose is that to be more like going towards the reproducibility, we need to have a full picture of truth or reward, where it's not only going to having the final publication, it's a process where we essentially are now including the artifacts evaluation. So that's a key component that we are working with Marion, Dom, and Cass, and Rolly that is now here, and Andrew, and others from the Climate Informatics community, and essentially is where we are making emphasis to try to improve, because I guess one of the problems that we have more in the climate or geoscientists is we are self-taught in programming. So we hope that through this experience with the research infrastructure roles, we can improve these kind of artifacts and be then more exposed to be reusable. That's the end goal. Something that is maybe going to change about this challenge, and it was a good question from the participants, is that they say, why I'm reproducing others' paper, what is the goal? So maybe something that is going to be very positive now that you have this artifact evaluation and you can have, say, this paper is reproducible or functional. Maybe we can have with the ADIS book, we can run a replicability challenge where the participants are going to use other data set and trying to get the similar insights from the original paper, and that could be more challenging for that person who asked why I'm reproducing other papers. And just to mention, these dimensions are very important. So we need to strengthen these guidelines for open and reproducible science, and as well, it's very important to do this capacity building, and this is the way what we see at the end. Everyone will have acknowledgement, and the funding should be across all these different like challenges. Yeah, I just want to end like this was not just people who contribute this paper. Many people get involved in this challenge. So a big shout to everyone who is here in the audience and participating in this. So yeah, that's me. Thank you.
All right. Hi, everyone. I'm Dominic Orchard. So as mentioned, I'm the Computer Science Co-Director of ICCS, the Institute of Computing for Climate Science at Cambridge. I also have another job. I do have two jobs. I work at the University of Kent as well, where I'm part of the Programming Languages and Systems group there. So my background is in computer science. and particularly in programming languages. So my background's in kind of theoretical computer science to do with programming language design and semantics, where I did my PhD, but I'm also a hacker and I like making things and creating things. So I always wanted to kind of build tools and build things that people could use. And at the end of my PhD, I started thinking about scientists, and particularly earth scientists, climate scientists, and thinking, well, why don't I start talking to them and seeing if we can build tools and languages and systems that help them do their work, which was about 10 years ago now. So how did I get here? That was one of the questions I was asked for these slides. And in the sort of early days of having conversations with various scientists, me and one of my colleagues at Cambridge, Andy Rice, we wrote this position paper called a Computational Science Agenda for Programming Language Research, that was kind of looking at the interesting programming language challenges that come out from modern scientific work where programming is absolutely essential. And one of the focuses in here was about the role of reproducibility and replicability. So a little quote from here. We're talking about the benefit that computational modeling has had on the scientific method. However, at the same time, this has substantially increased the complexity of making predictions from a hypothesis and reproducing the results. So this was something that we were sort of thinking about in those days, and how we can sort of support people in reproducible science. So from there, I got a bit involved with the Software Sustainability Institute, which many of you will be familiar with. It's a UK kind of institution to support the role of software in all the disciplines, really. There's lots of scientists, but there's also people from the humanities there, and supporting people who are embedding computational ideas in their research field and promoting good practice. So I became a fellow in 2015 of that through my work, also working with scientists and helping them. One thing led to another, and then in 2022 we started ICCS, with the mission to support climate scientists through the latest work in computer science, software engineering, machine learning, and data science. And a big part of that is a focus on helping scientists produce code that's reproducible and that's open and transparent, and sort of training people up and working alongside people with projects where reproducibility is really at the core. So that's perhaps a kind of slightly thinking about some of the sort of scientific background and how I came to this. But also in the context of this panel and what Cass will talk about later, I wanted to mention, I did more than 3 slides, sorry. How did I get here in terms of things like artifact evaluation and reproducibility? So in the computer science domain, I'll go back slightly, sorry. So in computer science, about 10 years ago, there was a big shift in terms of saying, okay, we write lots of papers and that's how people get credit in our field, but most of this has code behind it and no one ever looks at that code and it disappears into a black hole. And if someone wants to go and use that, you email the authors and they say, oh, mumble, mumble, mumble. It was on that computer that I left on a train in Munich, or my postdoc had it, but he left and went to Google. And or maybe the PhD student, she did all that work and oh no, okay, they're doing something else now and they can't find it. So there was a big process that went on about 10 years ago in many computer science venues saying, okay, what we should have is an additional review process that evaluates the code and the data that's come from research, and have a sort of what's called the artifact evaluation system that happens after peer review. So I was on a committee, one of the sort of early ones in the programming languages research field. This is the European Conference on Object-Oriented Programming. So I was a reviewer of people's artifacts that they submitted. They had their papers accepted and they were submitting the code. And we were looking, does the code actually really support what the claims are of the paper? So in my kind of computer science work over the last decade, I've been on the other side, and I had a quick count earlier, 9 artifacts evaluated by these kind of processes and published. Some of those have been tricky because sometimes they involve data or code that's proprietary. One of those papers involved MetOffice code, which is closed source, so we had to think about how to present that in the right way, and we couldn't give that to the reviewers. So these are various things, and in the computing world, there's these sort of badges, and there's lots of documentation and systems about how to do this now. So I've gone through lots of different iterations of this process, and some have been different at different contexts and different ways of evaluating it. And one of my students, a couple of years ago, we won the Distinguished Artifact Award, which for a big piece of software that we've been really working on for quite a long time and published several papers on, and we got that recognition, which we're really happy about. And I've been involved then in mentoring students, both on the side of reviewing artifacts and then preparing their artifacts for this kind of reproducibility kind of checking and evaluation process. So I was also asked, what am I currently thinking about? So there's the idea of reproducibility, where you have your code and you make it available, and a different team should be able to run it and get the same results. But for a long time, and going back to this 2014 paper, we've also been thinking about this sort of harder problem of replicability, where it's a different team but different code or different data. Maybe that's, okay, you take the model and you try it in a different situation with different data, or you write an entirely new model and try to reproduce the claims of the paper, but writing the code yourself. And this is really a bit more of an extreme and harder to achieve thing. So a long-running kind of earworm for me has been about programming languages that actually support this by better describing the science that's embodied in our code, and having code that actually explains more how it connects with the core science. What are the units of measure of these things? What equations has it been derived from? What were the discretization and approximation techniques embodied in this? That way, the code is easier to understand, and it's possible for people to start going from the reproduction to the replication. So it's something I think quite a lot about. I was also asked, what am I currently working on? So we work with a number of international scientific projects through the Virtual Earth System Research Institute, and we have our team of wonderful research software engineers who work with them on modeling projects. And as Marion said, a big part of that is embedding reproducibility in there from the start. In my other job at the University of Kent, I recently started a new research software community, kind of community of practice, trying to encourage all of these things across several disciplines, actually. So we've managed to agglomerate various people across the university who are writing code, and then we're getting into the kind of the training and how do you produce research that keeps on having impact after you've published that paper. All right, thanks very much.
Great. Thank you. Thanks so much. So really speedy tours through everyone's sort of backgrounds and things here, but one thing that I think we can all relate to is that experience of trying to run someone else's code, or being the person who gets the question, this student wrote this, or this postdoc wrote this, and now they've gone, and what can we do? How can we make sure that the things that are produced during people's works actually continue to have a life after that person's left, getting more value from the outputs that we create. But really those challenging situations, facing those challenges has been what's brought a lot of us to this, and I think that's the bit we can mostly relate to. So with our eye on values around transparency in this sort of open science reproducibility world, wondered if you would like to say anything about the challenges that you've faced in your own work in terms of reproducibility. And Dom's nodding, so we'll start with Dom first and then we'll move down here.
Okay, great. Well, a big challenge is doing things too late. So what I found, my experience is that if you try and put these things in once you've done a lot of the project, then it's really painful, because human beings have quite terrible memories, to be honest. So you think, how did we produce this, and how was this done, and oh no, where's this script, and blah 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 blah. So the challenge is getting it in as early as possible. And we've done various projects where we've helped people with reproducibility, where we've come in after the fact, and you can see it's much more difficult if you're approaching things at the end. And I've done it in my own work, where it's, we have to produce the artifact now. Okay, we need a script to reproduce this figure. Oh, we don't have it. How did we get this figure? Getting things in as early as possible is a key.
And that's hard. That's an incentive thing as well, right? It's no one's got the time at the beginning of the project, but we really have to try and switch our thinking to doing the work early on, whilst it's fresh. Absolutely. And while we've got the time to do it, and knowing that that'll bring value later in the process. Alejandro, how about you?
Yeah, maybe based on the experience of the reproducibility challenge, I can say that just mentioning the feedback that we have from the participants, like we have one that was asking, why I'm reproducing this paper, what is the added value as me doing this? So that was a very interesting question that we have, and I guess that person maybe wasn't aware about the value that maybe if someone can have a look of his code or her code or their code and potentially get feedback. And I guess the experience with the reproducibility challenge was that, like demonstrating that reproducibility is not easy to do, right? So when they have a look of all code and go there, is a way that you can find challenges that then you say, okay, I'm doing wrong things as well in my code. So I was a kind of feedback to themselves. I encourage everyone trying to do that, even with your code. I guess you can see your code and see how difficult it could be to do your stuff. And maybe something that you mentioned, the incentive, I guess is a clear problem that we have when reproducibility, I guess. That's why I think we should find other ways that we have funding to find incentives of reproduction reports, and they are valuable, and as well people who are part of the reproduction report, they have a scientific recognition. So I guess that are the kind of my points to the question.
Yeah, thinking maybe a bit more not on about these artificial, if you will, situations of having a reproducibility challenge, but actually the work on the code. I think what Dominic and Alejandro said both is true. It's also, if I'm working on my own code, I kind of get a bit ignorant about what people might not know because you're just so used to it. So just getting into a habit of writing things down, and basically as soon as you start working on something, start working your handover document, if you will. So just make sure that everything is documented, and everything you might just think about, oh, why is this, or how do I do that? Just write it down and imagine, you win the lottery tomorrow and you're gone and somebody else has to pick up from where you left. But also when you're working as an RSE with researchers, getting the buy-in, both from the incentive side, but also from just lowering the barrier. So don't make it scary, or don't make it something that basically people might feel embarrassed about. So thinking like, oh, they are judging me, and I might actually compare badly against their criteria. So just making it clear this is a difficult thing, and we don't need to basically solve the whole thing and make it basically handover ready in 1 week or so, but we're just working on it, and we're identifying issues, and then making those changes.
And that's a big step, right? Moving from kind of being okay with your imperfections and being comfortable with the discomfort of putting something out in a public domain, which might not be perfect. But then obviously what that opens up is the opportunity for people to catch your errors, but also catch the bits that you're missing in terms of the documentation as well. So one of the things that we do in the Turing Way and other projects is really encourage people to put out stuff as messy as you feel brave enough to do. So if you look at any of my GitHub repos, there'll be like bits missing and issues and things. And it's like, this is me and us showing you that it's okay to be vulnerable as a scientist, because you are humans and we make mistakes and we don't have complete information. And the rest of us, we can all work together to add into that. Do you have any experiences of doing that, of putting your code out and finding other people catching bits, or finding bits in other folks' works, or anything like that? Or how does that make you feel doing that, or the first time you had to do that brave thing?
Yeah, I can say my experience, I guess, for me, since, for instance, I joined the Turing, I was more like confidence to publish my code, even I have mistakes, and early stage research was okay for me, because I see that there are many people out there in the open science community, open source community, who are interested too. Even you have a contribution that it looks minimal for you, for them it could be very valuable, and there is this global knowledge in this open source community where you can have this feedback. During my master and PhD, I failed because I have my closed software until I have the publication and so on, but I guess according to my experience, where possible, you need to figure out that there is a community out there that can help you, that the way that you can maximize impact is making your code open if possible, and it's something that I encourage.
The difficult thing is that it has a time cost. So when someone, you know, you're working away on something else, and then you get that email from GitHub saying, someone's raised an issue on your repo. You look at it and you go,
Thank you.
or maybe look at it and go, oh, I'm not going to deal with that. Or you look at it and think, oh, that shouldn't be a problem. Why is that a problem? But it's good, and it's not easy, but lots of things that are worth doing are not easy. So sometimes it is that vulnerability, and then it's then working out how to fit that in amongst other things. You know, you can't maintain everything forever. I have things on GitHub that I get pull requests for and issues for, and it's just sort of, I'm not sure when I'm going to have time to do this. So, but if you're building something, if you've got a kind of trajectory that you're going, you've got this sort of piece of software that you believe in, and that you're able to generate results from, that you're kind of putting your eggs in that basket, then it's really valuable to have that input from community, and that thing that you didn't notice, you think, oh, that's great, okay, it's this free labor, okay, it has a cost, but I think it's just trying to use that, and then thinking about your own priorities. You know, is this a piece of software that I actually, you know, I want to keep maintaining, I want to keep developing, it's going to be important for my career, or it's going to be important for the community, or important for humanity or the scientific literature, then you can look at that calculus and say, yes, I'm going to focus on that. Or maybe it's, okay, that's had its day and it's in maintenance mode, and I probably won't be able to deal with that.
And then, of course, when it gets to that stage, it could easily be picked up by someone else.
Yeah.
And that reignites interest in it, and then there's a whole community that can support it. And just to note, we'll come to a Q&A section at the end, but you can obviously put questions in Slido, and we'll bring them in as well. And Marion, you mentioned onboarding your RSEs. Do you have to do any work to help them overcome that barrier of like putting out imperfect things, or are they totally ready for that from day one?
Well, ask Serbi, are you ready?
Yeah, she does a good job.
Yeah, I think that it really depends, and I mean, I think I'm guilty of that myself, that sometimes you feel like, yeah, I'll tweak this branch a bit longer until I push it. So, because sometimes you feel a bit embarrassed, you feel like, I really don't know what I'm doing here, and so, but that then delays the feedback, and that means that, you actually can't develop in the pace that you maybe could if you got this feedback and so. But I can very much understand that people are not always feeling ready to do that straight away. So especially if it's in an area where they feel they are a bit out of their comfort zone.
And that's where something like a repro hack, so like any opportunities to get together with other people to do this kind of interrogation and fixing work can be so successful, because then you're in a room with people where you all recognize that you're all vulnerable and you're all making mistakes, but you're kind of doing it together. So there's like a safety in numbers kind of thing. So as a community manager, I really, really value those times where we can get together and share our experiences and pain and what we can learn from them.
Yeah, and that's the feedback that I get from participants, that they say, so even people who are relatively new to coding, and so who say like, okay, I was sitting in a group and I just realized, okay, other people who've been coding much longer than I have these problems as well, and others are also not able to just install everything and it runs or so, and just seeing also how others approach these problems. So because just because you've been doing this for a couple of years doesn't mean it works out of the box, but you might have a set of tools of, okay, I'm now trying this, or I'm changing my strategy here, and so and that's the really valuable thing, that you can learn at the repro hack how other people are doing this.
Nice. So we'll move on to something a bit more positive, just a short bit of discussion about what's your vision for, like, what do you think this world should look like, and what systems do we need to change, what political structures or incentives do we need to smash in order to achieve this situation where everyone is entirely comfortable and confident with producing reproducible materials and the value that that will bring to our kind of scientific endeavors. What does that look like to you? Marion's smiling, so we'll go with you first.
Yeah, well,
smash all the structures.
No, my first idea was just every repro to have a
read me.
Right, little things.
Yes.
Right?
So something to that's just relatively easy to have, like a read me with a quick start guide, which basically lets somebody to copy paste stuff and copy paste the installation instructions and copy paste the quick start example to run something, and that would already make such a difference. But if you're talking about bigger things, so I think there's really kind of this stigma around failure in a wider sense, so that it's this thing where you're kind of not allowed to say, okay, I tried and I failed. And we had this discussion actually around our reproducibility initiative, so how anonymous it needs to be and whether people need to be allowed to basically just pretend they didn't try, because they don't want to say, okay, I tried basically to get the reproducible badge, but I only got the functional badge, so I'll just pretend I just tried the functional one. So and that's the thing where I think, like, is it really so bad to say I've tried? So is it so such a bad thing to basically have aimed somewhere and then for some reason, and it might be not that you've been bad or that you've not had the skills, so that it didn't work out. And I think that's something in general or in society or so that would be good to work on.
Nice, thank you. And Alejandro, and then we'll get to Dom.
Yeah, and just to add that I'm very lucky to have Don and Marion bringing this expertise, because we run this repository challenge with what I have a knowledge of Jupyter Notebook, but when I know more about artifact evaluation, I found this is the way to go, because the framework as we are having with the challenge is going to be collaborative, and as these are changes that we need to change, we need to think in the future the vision, like everything should be collaborative as possible, close where necessary, in this case anonymous. And maybe something that I would like to mention is with my slide that I mentioned is the funding and the trust and reward, that we need to find a way that we can have this artifact evaluation with more funding and not just having reward from the publication only, and trying to incentivize others. Another aspect that maybe is not covered and is in the paper is that how important it is to get involved research infrastructure roles in the early stage of in our research, and that can make our work more useful. What I mean, research infrastructure roles, like we have community managers, we have research software engineers, we have data wranglers, all these kind of different roles. I guess we should find more funding in the institution, university, to have these different roles and support early career scientists or doing research to in early stage of your research try to have your research useful and reproducible. So yeah, those are my points of view.
Great, thank you. Plug for my job as well, so thanks for that. Thank you. Dom.
Yeah, I mean, we're sort of thinking about funding that really gets into the wider political context, and I mean, people here from lots of different countries. I know there'll be a lot of people from the UK. I perceive that there has been a change in the way that funding bodies view the role of software. There's been definitely big jumps ahead in the UK with initiatives like the Software Sustainability Institute, being able to advocate for research software engineering and kind of push the government research councils to consider the role of software in research and being able to cost in research software engineers and things like that. Maybe you're in a country that doesn't have that, or I still think there's sort of a way we can go in the UK. So I suppose I would say that we need to keep pushing on the importance of software to research. And so if you're early career, I would say be proud of what you're doing. You can get a huge amount of benefit and impact, both scientifically and in the wider community, by developing good software that's reproducible and reusable, and that will in turn have an impact on the research culture and the field that you're in, the subfield that you're in. the people around you, when people can see that, oh, they built this and they built a community out of it, and then other people took it and published papers on it, and it sort of pushes out slowly, and then you'll probably at one point find yourself in a conversation with someone from a research council who says, okay, so what's important in your field? And then you can say, well, software is really important and we need more funding to support that because it goes on and it has an impact on all these other areas. So I think change happens slowly and it happens sort of often from the ground up. But people in research councils are often listening to the communities, and there are those conversations that some of you will already be having, I'm sure, with funding bodies and funding managers, and conversations that you'll find yourselves in at some point. And there is change happening, and it's great, but there's still more to do. So kind of look out for those opportunities to talk to the people who are involved with government funding agencies or philanthropic bodies. They want to know from the scientists what's important in the community, so make sure you can be ready to have those conversations and give a good sort of defense and be a proponent of the role of software in research, whether that's for modelling or analysis or otherwise.
Lovely, thank you. So we'll take some Q&A. I'll start with Slido while you're having thoughts, and the room mics will be coming around. So there are some spicy questions, but we'll go with the practical one first. So how do you negotiate challenges with the reliance on GPUs, CUDA libraries and toolkits, and the variety of hardware and cloud platform version incompatibilities? That was not the spicy question. Yeah.
I think one thing that you have to, so that comes up there very quickly when you talk about reproducibility is, containers, Spark, and the likes of environment management. And this is actually the crucial thing, and the thing that when you're doing a repro hack, most things fail at this initial stage of, oh, actually, how do I get this to run? Because these libraries are not compatible, and nobody told me that. And I mean, the first step already is the README. Again, if you say, okay, these are our dependencies and include the versions. So, but the next steps would actually to use something like Poetry or a TOML file or so, in the better case also something like containers or so, to make sure, okay, this is actually how it can run. And
Containers. Nice. Any questions from the room? There we go. Oh, lovely hands. Lola, your choice, dealer's choice. Go for it. Thank you.
Hi, thank you. Well, thanks for this is a very nice discussion. So I agree with a lot that has been said in terms of how worth it is to do this work, and the impact that it has to be. Something I'm really worried about is that I think the burden of doing so seems to fall onto the most junior members of the community, who are also the most vulnerable. Right, so I think it's like graduate students and postdocs. I think when we ask them to do all these things, to spend time documenting the work, to spend time becoming better software scientists, we are also taking away from the time that they can spend in research, which is most of what they are evaluated about, unfortunately. And and this is what will get them the next job. So my personal point of view has been that we need to hire more software scientists and take some load off of them. But I also think maybe we could think of changing the culture of what's rewarded, and I was wondering if you have ideas about this, right? Writing 2 well-documented papers takes the same time as writing 4 poorly documented papers, but 4 papers look better. So what can we do to change this?
Yeah, thanks for the question. So I think that if you embed things from the beginning, that a lot of these approaches, let's say kind of good software practice, ends up having it helps things down the line, and it speeds things up in the long run. So there is a bit of an initial cost, But then if you're saving lots of time down the line of what does this code do, why is it crashing, how do I debug this, how do I reproduce the figures because I need to do this revision for the journal, actually it ends up saving time in the long run. So I think it's really, once you embed things from the beginning, then actually the cost is not as much as it can sometimes look when you try and add things on the outside. And I think another thing about, to pick up on what you're saying about the responsibilities falling on the early career, well, I guess that's a challenge for everyone who's not early career to actually lead from the top and actually get involved and reskill and learn these things as well and actually lead and show leadership there and actually enable the younger scientists to do the science and to build their careers by saying, oh yeah, don't worry, I'll go write the README and I'll go and build the makefile and actually doing some of it themselves to enable the early careers to focus as well. So I would say it's a really great point, and so I would challenge everyone who's not an early career researcher to get involved and get stuck in and help them and lead from the top.
And just on that point of the time saving, that's often like a line that you hear. It's like, oh, but it'll save you time in the future. But until you've actually experienced that for yourself in your own work, that can be a bit intangible and you think, oh, is that just a pipe dream? But I've definitely seen it in my own work, and where I was supported by my PI, would let us do what we were passionate about, and I was passionate about reproducibility, so I put a lot of effort into developing a behavioural assessment and doing it really well, and then we got to give that out to so many people and bring in so many new collaborators, and that work of introducing other people to our processes was made so much more efficient and much easier for her to report on as well, which was great for the PI, because then she could see how many people are contributing to the repo, or how many people we'd given access to it and things. So it really is a kind of a process change that I would just encourage you to try out for yourself. Give yourself some time, or give your team some time to really focus on it and see the benefit for yourselves, and then you can trot out the line of it's actually beneficial in the long run. Marion.
Just to pick up this question contained a lot of different things, so to pick up some of the others. About what's actually valued in research, this is the big thing that the Software Sustainability Institute and the research software engineering community is talking about a bit, and I know that in data and so and with the Turing way, and so there's a lot of discussions around these things as well, that we kind of need to value not only paper output, but that there are so many different things of or outputs and work basically that goes into research that's undervalued, and there are initiatives like the Hidden Ref by the Software Sustainability Institute that tries to basically draw attention to that and tries to lobby for better recognition of these outputs, and that can be a piece of music, or that can be the community manager work, and there are so many things that feed into research, and that can be counted by how often your paper was cited or so. There was another thing that yes, and then the other thing is also the question of teaching the computational skills and so, and that there's actually a lot that should be taught at the undergraduate, or at least the graduate level, that isn't. So there's so much self-taught stuff that you have to do. So I think that a large percentage of what you're doing as a researcher, actually you have to teach yourself or pick up from your colleagues or so, and programming and dealing with data and all these kind of things are to a large extent that. And and the question really is, okay, at what point can we really do this? And there have been initiatives and there have been things set up also around these computational skills and so, and to bring them more into your studies and so. But then I come to the conclusion, or no, I don't come to the conclusion, to the question, do we need to come to a point where research software engineers are no longer needed, but researchers have the time? Or do we need to have more research software engineers so that those who are actually not that interested in the software side can spend less time dealing with that part and work closely together with the RSEs to do that? And I think it's kind of the mixture of both, because different groups work differently, different fields work differently, and also different people have different interests. So I think I could keep talking about this for an hour, but that's not.
So we'll come to another question on Slido, and then we'll come to the audience, if that's okay. So this is a spicy one. I'm going to take it to you, Alejandro. So while open sourcing is an idealistic goal, what are your thoughts on navigating the challenges of confidential and security sensitive code?
Yeah, that's a good question. I mean, like, I stress always, like, I'm very into the open movement, where possible share what you can see. There are, like, of course, no sensitive information, but where you have the sensitive information close, or there are tools that you can do some encryptation of the information and maybe supported with people who can do some like anonymized version of your data set, but share or sample all your data set if it's very sensitive information behind that. There are many, I guess, advanced on that regard, so I don't see any problem about sensitive information now, because there are many tools to anonymize or sharing sample of your data or your methods where possible. But I guess open sourcing for me is like, it's been like a good way to find this global community where people can contribute, or you can build on existing resources and not reinventing the wheel. So I guess that's the way that I see that open sourcing is very positive. That's my answer about sensitive information.
I think there's a few ways to interpret the question, but the one thing that I've come across is when you're in a situation with proprietary data, the license isn't there, you can't share that data. So I think in that context, what you can do instead is have some other kind of data that's sort of representative, that you can still give some results on and say, okay, this is how you can look at this code with this other piece of data that gives you confidence that this code does what it says it does, because you can reproduce it on this different data set. And okay, we had this other thing with this proprietary data product. Of course, then you can't share it, but you have some sort of alternate which you can give to people so that they can evaluate your work, its claims, let's say. So it depends what you sort of want to get out of it. Another aspect is if the code itself is proprietary, or sensitive in some way, and then I think that somewhat goes back to the thing I said right at the beginning about being able to describe enough so that someone else could go and create their own code, and having enough description and explanation of that so that someone could go and replicate the results even if they can't actually ever see your code or run it.
So the recent big papers and results in AI, both in AI for weather, but also on a lot of other applications, required a lot of compute and a lot of data. So first, I want to mention there's a climate change impact to actually try to reproduce those. But second, how do you advise on reproducing those sorts of things? So like, it's great that ECMWF allows us to play around with them, but like we tried to implement Pangu, or just apply Pangu code on a coarser resolution Era 5 instance, because that's what we can support, and we're not getting the same results. So how do we, so like the actual very impactful papers in computer vision or machine learning, it's extremely hard for us to reproduce. So any guidance there?
Yeah, I will mention only like if those ones that create this kind of like crazy papers, they can provide a kind of like test user accounts to someone external come onto that infrastructure and test there over there. For instance, I guess there is I've been following the US, they have Chameleon and something like that, like supercomputer, but the good thing that you can reproduce, and they are like supercomputers, and you can follow all what other researchers run with the large experiments. And people can try to get into your workspace and try to run your code. So I don't know to what extent that can be helpful to someone try to run this with large infrastructure, but I don't know.
I think there's a question there of who takes the burden of responsibility for doing that kind of work, and is it the funders? Is it the authors of these big things? You know, if they can write their grants with spec'd in a piece to say, we can also provide some infrastructure for other people to run our tools on some, you know, TRE or something, you know. It's an unresolved question, I think, you know, and the important bit is industry and the infrastructure. So it's, I think as long as we're having these conversations and you're raising the fact that you want to be able to reproduce this work, but you can't because you don't have the infrastructure and you don't have the funding, it's like, have those conversations with the funders and where can these challenges be raised?
Yeah, so in the reproducibility challenge at the supercomputing, what we did in cases where we did not, so where it was crucial on which machine the code was run and we could not get access, is that we basically had a Zoom call with the developers and let them run us through the steps. So it was not so much the reproducing then on our side or so, but basically making sure that there's another set of eyes basically looking at it and having the plausibility check, okay, these are the steps and I can show you that this happened. And so, I mean, and for maybe not for the cases that you described, but there might be cases where you can have a scaled down version of your code where you can basically show some plausibility checks and so, or basically part results that you can reproduce or so. The other thing would be just have an external basically to talk them through what you're doing and see whether that makes sense to them.
So we started a few minutes late with, because you're all enjoying your coffee, fantastically. So we'll take one more short question from the audience if anyone's got one. Thank you. You were very quick with the hand back there. There's a person back at here. Spotted different direction.
Sorry.
We'll take your question later.
I would like to add on Claire's question. Imagining research groups that have very small resources or the global south, and then dealing with very complex model scenarios, what kind of stimulus in terms of like educational and research policies do you think that needs to be made in terms of like accessibility of shared resources or support for training globally? Can you expand a little bit what your thoughts on that, like on making more accessible?
All of those things. If you don't want to answer us.
Sorry. Yeah.
Go for it, yeah.
Yeah, maybe I just want to make the case of some community-driven example like Binder. Binder started like something with like resources and trying to make like everyone around the globe can run minimal examples over there, and this Binder was created with a report to Docker, images and so on, but it's making it easier for anyone around the world and it democratizes. So I would like to see more this kind of initiative where like different like data or like computing centers can provide resources and invest on those kind of aspects and be more democratizing over other areas of the world, because I'm coming from the global south and I totally agree that comment on that comment. There is an initiative based on this Binder that is 2I2C, that is an NGO, no-profit company, and they are trying to make computational research, the resource, the cloud computing more accessible for other areas around the world. So I guess this kind of initiatives are something that I myself, like coming from the global south, I am totally support, and I would like to see from the global north investing and providing resources and have more federate learning and invest in those areas that we don't have resources. Yeah.
Great, so unfortunately we're going to have to wrap up there. If we can just transition to the next slide. So there's some really nice questions on should we just send back everything to reviewers if we don't have code? Should we just reject everything that doesn't have code if you're reviewing? You can do that if you want to take that stance. How is ChatGPT going to affect reproducibility of things? So there's masses of things to think about in this space. So I just wanted to give a formal plug for the artifact evaluation challenge artifact evaluation process that we're setting up to support full papers that have been submitted to this conference. So those authors are going to be asked to submit their artifacts for review, and it's going to be a collaborative review. It's not just a committee of people against you trying to find holes in your code and your data. It's actually how can we help you develop your artifacts into something that more people can benefit from. So to do that, we need authors to submit your artifacts, but we also need reviewers. So we're developing training and resourcing for those reviewers. And we're very, very aware of the work and labor that's going to go, that those reviewers are going to have to undertake in order to, do this evaluation process. So we're aware of the incentives and trying to create value in that for you. So if you think you would like to contribute to that review process, if you've got a minimum skill level of what GitHub is and you know how to do some coding, then come to us, speak to us after the event, and we'll be running some online sessions, and we hope to grow this as a community of people. And as a reviewer, you learn how to produce your own artifacts, right? You'll learn best from looking at other people's materials. So the date is TBC of when we're going to be opening up the artifact submission process, but it should be a short period, and having a community and support team for the reviewers and the authors as well. So if this is something you're interested in, come and speak to any of us. And thank you very much for your questions and attention today.